glimpse of the future. I mentioned yesterday in the introduction to the conference that this is meant really to be, it's not a speculative academic discussion, it's meant to be on the ground, in the trenches. This is the spirit of this conference. But there is an exception. We have this tradition now, which we built over the several editions of the conference, to program one lecture that is wildly speculative. It allows us to dream a bit, to see the future. And I'm delighted to welcome Andrew Kudless, who's going to fulfill this function for us. So Andrew is the Bill Candle Memorial Endowed Professor at the University of Houston's Hines College of Architecture and Design. He's also the director of their new Construction, Robotics, and Fabrication Technologies Lab. The acronym is ingeniously CRAFT Lab, which utilizes advanced digital technology, including construction robotics, full-scale 3D printing, did you hear that, Philip? And mixed reality. Andrew founded MATSIS, a design studio exploring the emerging relationships between architecture, engineering, biology, and computation. His latest projects are vigorously pushing the envelope in the use of AI in generating architectural form, putting him at the forefront of research in this emerging field. The work of MATSIS has been exhibited internationally and is in the permanent collections of the San Francisco Museum of Modern Art, the Centre Pompidou in Paris, and the FRAC Center in Orléans, France. His work on Confluence Park has won several awards, including the 2019 AIA National Honor Award. Please join me in welcoming Andrew Kudless.
I'm very happy to be here. Really exciting morning. So for the last session, I'm talking about the fabrication of architecture. This is going to be talking more kind of early design phase and how technology is affecting that, at least within my own practice. The talk is called 5 Points of Architecture and AI. And in 1923, so 100 years ago, Le Corbusier proposed his 5 points of architecture, a set of formal strategies rooted in the social and technological conditions of that era. 100 years later, we face our own social and technological challenges, ranging from the climate crisis, which we've heard about in the first few talks today, as well as in the last one, with different fabrication strategies to address more sustainability. To inequality and the emergence of artificial intelligence and automation. However, unlike the international style that arose from Le Corbusier's 5 points, today's implications are less formal and more, I'd say, disciplinary. Large language models, which probably you've heard a lot about in the news recently, like ChatGPT and things like that, include latent diffusion models, which is specifically around image and often text-to-image generation. And they rely on training data scraped from the internet. And they're as truthful in some ways as the underlying data. These models are essentially statistical predictors. Based on the patterns learned from the training data, the model attempts to predict a visual representation of the text prompt. Like us, the models are products of their training and are fallible, subjective, and incomplete in their knowledge. If I said the word city to you and asked you all to what you envisioned, it would be different for each of you based on your own experience. All of these understandings are correct, yet simultaneously they conflict with everyone else's understandings. All types of biases, from the benign to the insidious, are inherent in systems without significant human feedback that is diverse, collective, and non-hierarchical. That is, we begin to rewire our brains to overcome the limitations of our own experience through conversation, travel, and education. As architects and designers, we must question both the systemic biases embedded in the tools we use and the implicit biases we might bring to the design process ourselves. Our tools are the products of the social and economic conditions in which they're made. We are burdened by countless gaps between each of our own subjective experiences of the world and their imperfect representations of the collective media landscape. In these gaps lay opportunities to critically observe and thus confront how our designs meaningfully contribute to society. So I'm going to step through a couple of examples and discuss some of the most interesting features, or some people might call them bugs, that I found helpful in informing my understanding and use of these tools as a designer. So the first bias that I want to discuss is related to resolution. So unlike rendering, so for all the architects out there who do rendering, where you changing the render size of the image is simply a factor of processing time. If you have a very small resolution, it takes not a lot of time. If you have very large resolution, it might take more time, but essentially the content of that render will be the same. So models, AI models, used by platforms like Stable Diffusion and Midjourney are trained on images of a very specific resolution, often 512 by 512, and asks a very specific aspect ratio as well. So asking the model to produce images that don't conform to these parameters can produce surprising results. So here I prompted Stable Diffusion with the term macchia, a Japanese architectural typology that can be translated to a merchant's house. Trained on square 512 pixel images, the AI model has a difficult time focusing on the specific typology at any other resolution other than 512. As resolution increases, the image content tends to duplicate and obsess over specific features. So for the macchia prompt, the larger images have drifted towards an amalgam of dense urban form, signage, and trees. Changing the prompt to a street in Miami produces a similar set of images. While the street is clear at the lower resolution, as resolution increases, we lose the street as the palm trees and buildings merge into some type of strange megastructure. So what's causing this? And why does what does it tell us about how the model understands certain concepts? Forcing the model to produce at resolutions that are far outside of its training, it reverts to cliches and stereotypes related to that prompt. So this is kind of a strange analogy maybe, but you've probably heard when you're reading news articles about ChatGPT and other things, there's a thing called latent space. It's a very hard thing to get your head around, and the best way that I've tried to kind of build an analogy for myself is that each word, or even sometimes sections of words, you can think of them having a vector. It's like a direction and a magnitude towards the place in latent space that the model has created based on its training. So for Miami, there's a vector towards Miami, or street, and so forth. So the way I kind of think about that is if you imagine like the whole universe of all knowledge, at least knowledge that's on the internet from the training, you think of that as this gigantic universe. And in that universe, there's different galaxies, and within each galaxy, there are different solar systems and planetary systems and moons and so forth. That, in this case, for instance, the word macchia might be just like, kind of think of it as like this moon that represents macchia that's orbiting around like a planet that is maybe traditional Japanese architecture. And that planet is in the solar system of Japanese architecture, and that is in the larger galaxy of architecture. So what happens as you begin to change the resolution, the model just is having a very hard time kind of focusing on the specifics of things, and it's almost like a blurry vision in a way. And it's kind of zooming out and only able to kind of focus on, in some ways, kind of the stereotypes or some larger topics of it. So, for instance, here, the prompt street in Miami, at the very bottom, you kind of see something that looks street-like, but each street in Miami looks slightly different, and as it kind of zooms out, it's having a harder time kind of visualizing streetness, and it just begins to like focus on what is a cliche of of Miami, the palm tree, and it just begins to obsess over this palm tree, and you can kind of see buildings growing out of palm trees and so forth. So in the next example, rather than change the resolution with the same prompt, I was curious how changing a simple prompt while keeping the same seed and an extreme resolution, like I was doing previously, would tease out these stereotypes that the model has about a variety of cities. So I ran the same prompt on the 81 cities that the UN determined had a population of 5 million people or more as of 2018. So because the Stable Diffusion model can be deterministic using the same seed, unlike Midjourney that will always give you kind of a different result even with the same seed, you're able to compare the effect of minor changes to the prompt. So here I selected 10, the results were pretty shocking to me. Color was the immediate difference, so these are the 81 cities, and I know at the scale you can't quite see the differences, but there are some immediate things that you can see, mostly related to color. So Europe and North America were almost always gray and low saturation. China and Japan were always red. South America, Africa, and the rest of Asia were always colorful. So the prompt was just like the street in Miami. It was a street in X where the script just went through X as a variable and replaced it with each of the 81 cities. So it was street in Tokyo, Delhi, Mexico City, Cairo, New York, Lagos, Rio de Janeiro, Los Angeles, which in some ways looks a little bit like Miami, according to Stable Diffusion, London, Barcelona, and then back to Delhi here. And I actually for all those previous 10 images, I wasn't really showing you the full prompt. When I initially ran this example, this generation with a street in X, a street in one of these cities, one of the things that I began to see was that any city within Europe and North America, they looked kind of what you'd maybe expect in some ways, but any city outside of those two areas were almost entirely always made out of rags. There were people laying on the ground. It just looked like a city made out of kind of garbage and rags. And I think this is a really good demonstration of some of the biases in these models. That, as you all know, the internet is predominantly English language and also kind of has Western, a lot of content generated by Western civilizations. And so the model, in a way, is trained on all of this information. So it's trained on a perspective of these cities from a Western perspective. And so you can see a street in Delhi that it looked like, it's a modern cosmopolitan city, one of the biggest cities in the world. I'm sure there are poor areas of the city, but there are also poor areas of Miami and poor areas of Los Angeles. But it always would obsess over kind of the more tourist images of Western cities and kind of the slums of non-Western cities. It also assumed that the only difference between the 18 Chinese cities that had populations over 5 million was the quantity and shape of their red lanterns. So I don't think we can ever rule out all biases in these models, but I think moving towards a more diverse training set that isn't just a scrape of the web would be a very good start. The internet is heavily biased towards Western media and language. Although I think this helped make amazing progress in large language models, not only is the internet a biased source, but it is also mostly full of garbage data. All right, so the next point is the cultivation of sensibility. And this mostly, I'd say, focuses on the education of the designer. So what is the design sensibility? What is design sensibility other than the ability to predict the success or failure of an idea based on hints and fragments before you? Beginning design students often struggle because the design process is not simply a technical task with well-defined solutions, but an iterative series of decisions that integrate disparate fields of knowledge. We create pedagogical structures that allow students to test multiple ideas and learn from their failures. This process builds a design sensibility that allows a designer to draw from their experience and build hunches on new design problems. Working with AI tools can supercharge this educational process, as designers can envision their ideas within seconds. With new variations branching off at a dizzying rate, Current and past sketches can be blended. At dead ends, they can retrace their steps and explore a new branch. Ideas can be additively refined through the introduction of new references and concepts. This requires designers to develop the ability to express themselves through language in ways that rely on deep historical and cultural knowledge, as well as an understanding of how the knowledge aligns, or often doesn't align, with the specific model in use. Although it's often called prompt engineering, it's more like prompt poetry in that the text-to-image models reward users with better vocabularies and more knowledge of art and culture, and are able to use these to succinctly and eloquently describe their desires. However, designers will also need to understand where language and image fail to convey the critical information, especially concerning material and fabrication logics like we just saw in the previous panel. The use of AI is not a replacement for traditional design education, but an augmentation of what we already do in teaching students to be critical, yet open to a multitude of design criteria, and to use iteration to test out hypotheses. So over the last few months, I've produced over 30,000 images just with Midjourney and Stable Diffusion. With each image generation, I'm making several choices. Do I need to edit the prompt? Do I need more variations of the same prompt? I'm often making these decisions within seconds, and I don't worry too much if my decisions don't produce the desired results, as I can always go back and produce alternatives. The choices we make further train the AI model. However, the reverse is also true. Our consumption and analysis of the images changes our own mental models, and this affects our own intuition. That we train the model, but the model also trains us. Although there's an apparent sense of magic when you first start to use these text-to-image AI tools, this quickly dissipates as you become frustrated with the limitations of language. Just like speaking to another human, language can fail to convey what you intend. One of the most useful tools in this case is image-to-image generation. As the saying goes, a picture is worth 1,000 words. In this series of images, I start with a 3D model of my project Confluent Spark. From this, I extracted a depth map where surfaces in the foreground are rendered in white while those in the back are black. I can then use this depth map with an image model trained on reading the depth of images to transform it into a variety of materials. By varying the weight of the control depth map, the generated image begins to drift further from the source. These images can then be further blended and combined with new text prompts to further hybridize the original source image, allowing the pavilion to transform into a wicker chair or a timber pavilion instead of concrete. Okay, so the next is on what I'm calling the crisis of labor, which we also heard about briefly, but I'm going to talk about it in a different way. So the discipline of architecture has developed an unhealthy relationship with the labor necessary to produce good designs. In an almost cult-like way, the discipline has promoted long hours of tedious tasks for relatively low pay. Too many talented and passionate architects leave the profession because it is often incompatible with the pressures of everyday life. Rather than relieve this burden, technology often adds to it through steep learning curves, arcane workflows, and endless updates and conflicts. The technologies we use often are biased towards the tail end of the design process, with a focus on production and efficiency. Rather than view technology through a capitalist lens as a means to do more in less time, we need to reevaluate how it might create opportunities to augment our design process in meaningful ways while also removing the drudgery that has long plagued the profession. After 30 years of digital tools in architecture, generative AI tools are one of the only tools that help to expand the design imagination by focusing on the early design phases. Although it's fast, the value is less in its speed than in the fact that it challenges the designer to look at their ideas in a new light. Rather than days in Photoshop meticulously massaging an image that will have little impact on the design itself, designers can sketch a design's potential atmosphere in minutes without modeling a thing. Rather than the image only serving as a very late output within the design process, it becomes an integral part of its development. Architecture is inherently multidisciplinary and synthetic. It pulls from aesthetics, engineering, finance, construction, and ecology in creating a design that responds to its specific needs. Generative AI within the design discipline is in its infancy, but it can potentially augment the architect's task of integrating complex design criteria across various levels. Technology should be emancipatory. It should free us to do more of what we want to do rather than what we have to do. Unfortunately, too often this isn't the case, and we feel burdened by technology. For the profession to thrive, we need tools that augment our design abilities rather than make us feel like machines. Collages like this would have taken hours or days previously, but now can be generated and painted in minutes. I can express and visualize my ideas faster. And this isn't important simply so that I can do more work, but so I can sketch out ideas and explore my imagination more deeply. When I was an architecture student, I was terrible at drafting. Not just terrible, but slow. I would draw only 1 or 2 plans the whole term because that was all I could do. I needed to be very intentional with drawings as there wasn't time to explore a broader range of options. We've developed the opposite problem with computational design. With an infinite range of options available and the tools to nearly instantly model, draw, and visualize them, we drown in a flood of information. Mark Burry has described this as the stopping problem. How does the designer know when to stop when they have built or simply use a process that is able to produce an infinite number of options? Interestingly, Burry suggests that the answer circles back towards intentionality. With the careful construction of constraints and the intelligent use of their design judgment, and maybe even some computational optimization, the designer can steer the design towards their goal. The designer is a co-author in the process through their initial constraints and the eventual judgment and selection. So this is a video from NVIDIA's Canvas app that allows you to paint a 3D HDRI environment using simple brush strokes. Each color represents a different feature type: clouds, mountains, grasses, and rivers. You can swap out styles of landscape from desert to grasslands, etc. Although it only works at the moment with landscapes, I'm sure people are working on a similar model for architecture. This form of AI-assisted sketching will become the standard in the next few years for designers of all types. Okay, so the fourth is a redefinition of authorship. The incorporation of artificial intelligence tools in the design process poses a challenge to the conventional ideas of the solitary genius creator. Since these tools are trained on an imperfect approximation of human knowledge and their interfaces encourage interaction, engaging with them involves a social dimension akin to communicating with a knowledgeable but eccentric colleague. This interaction is marked by a reciprocal exchange of ideas, as well as frequent misunderstandings and occasional breakthroughs. Consequently, authorship becomes blurred, and instead we should direct our attention towards the collective process of creation and the resulting value of the design. Design has always been a cooperative effort between a designer, their material and tools, and the larger social and historical context in which they operate. This collaboration is shaped by a diverse range of living and non-living systems, including our direct collaborators, including clients, engineers, and fabricators, and the broader social, economic, and ecological networks that surround us, and even within us. The introduction of AI models and tools into this milieu has only further complicated the already intricate interconnections of contemporary design. By providing a vast yet imperfect simulation of collective knowledge, AI models have expanded and enhanced the designer's capacity to explore the human imagination and envision new possibilities. Okay, video is stuck here first. Still stuck. Oh well. This novel perspective acknowledges the complexity of the design process and rejects the outdated model of the master builder fully in control of all aspects of a design. Although our role is to synthesize disparate streams of information and competing criteria, we do this in partnership and solidarity with multiple overlapping and nested communities. The collaboration with generative AI tools adds a new layer to this understanding of shared authorship. I started my practice nearly 20 years ago, exploring the emergent systems such as casting plaster into elastic fabric. I was fascinated by the forms that I could help to create simply through the interaction of two materials under force. There's a resonance in this wall that has with our own bodies. People are drawn to it. It looks soft, but it's rock hard. And despite that, people want to feel and hug it. The wall and our bodies share geometries because we share a similar material process. The human body is essentially a liquid interior held back by an elastic skin and held up by a compressive skeleton. The forms that emerged in the wall were the result of similar interactions between the rigid frame, the elastic fabric, and the liquid slurry of plaster. As a designer, one of the things I learned from this series of projects was to give up control to these other forces. That is, I was a better designer when I partnered with other life and forces in the design process. I could create things that were beyond my own ability to draw or model. This process continued for me as a designer of the Confluence Park Pavilion. By working with the flow of water and the force of gravity, the form of the pavilion emerged as a series of funnels that challenged rainwater into an underground cistern. Throughout nearly all of my projects, I return again and again to ways of giving up control to other forces. In this drawing series, I was interested in designing a walled city, whose wall grew so big that it became the city instead of simply encompassing it. Using an algorithm that simulated natural growth patterns, the wall begins to fold back on itself as it extends and thickens. So Atlas is an ongoing project that started in 2017 with the walled city drawing that I just showed. And then here at the University of Miami in 2019, I co-taught a workshop on how to use generative computational tools to imagine and visualize fictional cities. Each city explores a different set of rules for how a city might develop over time. However, this isn't an urban planning project. I make no claims on the viability of these plans. Instead, they serve as artifacts that allow us to imagine different economies, political systems, building codes, and cultures that might produce such an urban formation. The Atlas is infinite and imaginary, and that I use it to push myself in learning new techniques and new ways of thinking about urban formations. They're computational sketches that spur my imagination. And then recently, I began to realize that I could use my generative drawings as seeds for the generative AI model. Each drawing is rethought through the model's understanding of actual urban patterns, learned from countless satellite photos. Rather than bicker over who is the author of what, I find it more productive to always think that I am a co-author with my tools. These tools have deep relationships with the vast media landscapes, as well as histories of technology and society. We are always creating with each other, past and present. Okay, so the fifth and last section is on the freedom of incoherence, which might sound a little strange, but I'm beginning to realize kind of the value of not making sense. The design process is not straightforward. It's characterized by complexities and contradictions that must coexist in the designer's mind and worked out in their drawings and models. However, most digital design tools prioritize accuracy and certainty, and as a result, they require designers to create workflows that quickly organize and structure their ideas, potentially prematurely. For earlier generations of designers, sketches were a place for ideas to exist in a state of radical incoherence, as the value of a sketch was its lack of resolution. Dimensions were inaccurate, perspectives were incorrect, and materials were absent, yet a sketch could convey the possibilities of a design and evoke its atmosphere. The value of a singular sketch was limited, but the accumulation of iterative sketches built up a designer's understanding and desire for a project. The challenge was to translate this vision into reality, where most digital tools developed over the last 30 years provide value. However, the early stage of incoherence is of great value to the designer, as it represents the inherent contradictions of design and the designer's own mind. For programmers in artificial intelligence, there's a constant effort to produce models that yield more coherent results. However, the most significant value of AI models for designers may be their ability to help navigate ideas without requiring immediate resolution. In a contemporary workflow, designers must construct complex parametric and bin models that are often fragile and limited in flexibility. We commit early, as the exploration of diverse ideas can be too challenging. The images created with generative AI, on the other hand, allow for investigation of a broader range of options without committing prematurely to specific design directions. These AI models enable the necessary messiness of design, but they do not conform to the geometry-based paradigm. The latent space of the model allows for an architecture before geometry. So nearly 25 years ago, I was living in Japan and became fascinated with these fabric structures that you can find now anywhere. I was used to the sprawling and dirty construction sites of the US, and these draped, tightly bound sites captured my imagination. So these are actual images, not AI generated. I began walking around Kyoto, Kobe, and Osaka, collecting as many photos. While I was there, I began making up projects for myself using these diaphanous fabric facades. But when I returned to the States, other professional directions took over. The difficulty of drawing, modeling, and rendering digital fabrics also intimidated me. There was a simplicity to the work that was not reflected in the media that I could use to represent it. However, last summer I began sketching an idea for a house with a fabric facade that breathes with the wind. These sketches are not a full design in the same way that a pencil sketches. They are explorations of the latent space of the design that exists in my own neural network. Through sketching, we make connections between memories and vision. I've resisted the urge to start the typical design process of trying to convert these images into 2D drawings or 3D models. I'm not ready yet for that in my own process. More recently, I've been using the extreme resolution kind of feature / bug in Stable Diffusion to produce intentionally incoherent images. There's a drive in the world of machine learning to lower what's called the FID score of generated images. The score measures the distance between a real image and a generated image, with low scores signifying the ability of a model to produce realistic imagery. I think as designers we need to resist this desire. Essentially, that if a model produces an image or a phrase of text or something like that, there's actually another model that is used to, it's like a judge. Like, is this thing real or not? It doesn't have to look realistic. It could be a painting, it could be graphic design. But if the generated image can trick this judge, then the score is lower. And I think we need to kind of resist that in some way, because I think as designers, the point isn't always for coherence. We have rendering engines that can produce accurate depictions of our desired realities. I think the value of generative AI images is in their ability to produce ambiguity and incoherent assemblages of form and atmosphere. I produce these images as a way to understand and visualize the latent space of my idea. They don't have to match reality, as my ideas don't match reality yet either. In addition, I have been intentionally forcing Stable Diffusion to produce glitches by using prompt weights that seem to break its desire for coherence. The images capture details for me that I want to see in the design of the house in its relationship with the landscape. I try never to use references to architects or artists or styles, and instead use very simple prompts describing what I want to see, weighted by how much I want to see it. I then begin to bring these images back towards reality by using image-to-image prompts or blends. By starting from an initial image or images, the model can achieve much more than the most complex text prompt. I'm able to pull in images that extend across the span of a project, sometimes even images from previous projects, to help me combine my memories and extend my imagination. I'm sure neither of these images are the final design of the house, but that's not my goal. After 30 years of the unrelenting logics of CAD drawings, parametric models, and complex render settings, I'm thankful for a tool that's easy to use and allows me to explore in a new way. At the same time, it comes with the heavy weight of the collective, computational, and cognitive biases that I've discussed today. However, I'd rather face these difficult reflections of our larger culture than look away. Thank you very much. Any questions? I'm happy to try to answer. The person behind you first, and then you.
So, when it comes to design and using the AI tool, it does open for you design freedom. But how does it address the core problem that you were addressing before, which is philosophical level, that is only expanding what is possible?
I couldn't quite hear the whole thing, but maybe try to rephrase it. That you're asking about how does it help you expand if it's only trained on existing things?
It's only, the question is, if it's only existed in what is possible within Western thinking, how can you go beyond that if the opportunity is already there?
Right.
At the philosophical level.
Yeah. Well, first, I think it's just to mention the philosophical issue, that I think it's one of the things that I've been most interested in teaching my own students is that after 20 years of teaching software, where it's just like so incredibly kind of meticulous and like technical, that it's often hard for the students to kind of get out and see the bigger picture. Like, what are the philosophical implications of using those tools or something like that. When I was teaching students this winter, I could teach the technical aspect of using these tools in like a half hour. So the next like the rest of the class is talking about the ethical, legal, philosophical issues that are kind of embedded in these. So that doesn't exactly answer your question, but I think it's a very good point that because it's trained on the internet, what's on the internet, there are massive gaps in its knowledge. So that's like a huge problem that we have to address. One of the ways of doing that, I think, is one of the big debates, let's say right now, and you've probably seen some of this, is the kind of argument between should this technology be kind of owned and controlled by like the big tech companies of Microsoft, Google, so on and so forth, or should it be, is it such an essential technology that it should be open sourced and made available freely to anyone, and that would hopefully, the optimistic side of that argument is that you could quickly increase the knowledge that each individual could train their own model. Each culture could train their own model. You'd have, instead of, Microsoft deciding what the answer might be to a question, that each individual could have more autonomy about what the model does. The pessimistic side of that argument is that if everyone has access to this technology, is everyone ready to have access to this technology? So there's kind of this like gatekeeping argument of where it should belong. I come down on the side that I think it will become such an essential technology that we have to make it almost like utility, that it's like everyone should have access to it. And based on the past 10, 15 years of experience with big tech companies, I don't quite trust them to make choices for everyone in the rest of the world. Yeah, I think that's probably it.
Like I said, the glimpse of the future. Unfortunately, we have to end now because we have to leave the room. Actually, there's another event. So thank you, Andrew. This is fascinating. We conclude the conference. Thank you all for joining us for the 2 days, braving the rain yesterday. And thank you to all our presenters today and keynote speakers and our sponsor, Kudless. We'll see you again next year. Thank you.